Hello everybody, welcome to you. This video is basically me excited to show a bit my work and to show how it's working. My projects are mainly open source, so feel free to go in the comment and ask where it is, how's the progress, or how, if you can use it. To make it short, in this video what I will do is talk a bit about the project and show some example of the progress of it, and at the end show a demo of how my code is used for the moment, and how you could think about your project. So why you should watch this video? It is if you have a game with plenty of objects that are kind of the same, that kind of far off the user, and in this case you should watch this video because it's really cool. So let's start it. The idea is that I'm working with a friend on a spaceship game, and as you can see here, the idea is that you have plenty of bullets. You have thousands of bullets in the game, literally thousands of bullets in the game. So at one point I was like, okay, but maybe what I should do is if I take all the bullets and I look far away and I do a little rectangular when they're too far, that is summarizing all the bullets behind the rectangular part. Okay, so as you can see here, that's what it looks like. So for example, you have plenty of bullets and they are summarized by one square like this. And to give you a bit of another example, here it's target of the object, the closer to the user, and so it looked like those kind of stuff. What it allowed me to do, it allowed me to do those kind of situation where you have all that, it's some pixel that representing the bullet behind, and it gives you this effect here in the second version, where basically the red mean there is no bullet, there is one to almost no bullet, and the yellow mean there is plenty of bullet behind this little square that is representing a pixel of the screen of the user. And as you can see here, it's really useful. What I did in my software is that I try to have a lot of objects, a lot of bullet on the Oculus Quest, and my friend is using all the GPU, so I'm working with the job system of Unity to be able to use all the CPU multi-threading of the Oculus Quest. So that is the topic I'm working on for the moment. So as you can see here, you have 4 states. You have the state of the pixel here, where basically the object is so far that you can resume it by a pixel and all the object behind. You have the more close one where it's just a square with texture you give the software, because at some point you need to have plenty of bullets that seem to be a bullet and have texture of it. Then when it's at a bit close but not too close, it becomes a drawable mesh. It means you give a mesh and a material and it will draw them all. And when it's really close, then you really need to transform with the object, the particle effect, the material, and so it becomes this stuff. So as you can see, you have pixel, some object between the both of them, the draw mesh, and then the transform. So you have those 4 states of advancement that allow you to spread the task of drawing those bullets, but with each time less and less performance use, but more and more bullets, because more it's far, more you have bullets. So that was the topic of the start of the project. But at one point, I realized something. You see this object over there? It has a square. It's like a square with some pixel, and it's 32 pixels on the screen of the Oculus Quest. So I was like, yeah, but why should I not use some texturing instead of having 3D mesh when it's those distance? And I was like, yeah, so on the Oculus Quest, so I did a small script that I will show you that allow you to evaluate how many pixels an object is representing on the screen. And so as you can see, some objects are kind of close, because here it's 100 unity distance and it's already for this object looking like 16 pixel. And this one, it's at 40 of the distance, 40, yeah, of distance is 32 pixels. So I realized that most of the objects in the quest are pixel on the screen. So you guess what I try to, where I try to go? I did a small script that allowed me to generate those. So basically you give the object and the anchor point of the object, and he zoom out with the camera, and when he arrived to a state where all the object is in the pixel you want, like for 32 or 60, he start to take screenshots of this small part of the screen all around in a GPS location. It means longitude and latitude of the object, and it make you a texture like this. And you guessed it, at the end it gives you something like this with the alpha of the, if you need to cut or use shader on it. And when you do a script that will try to guess what image should be displayed here instead of the object 3D, it gives you this kind of effect. And it took me a lot of time to have the code working, but now it's working. So you can just give an object and you say it should be this texture, this atlas of the object, and could you guess me what part of this texture need to be used? And then it will give you a part of the big mesh that is the good image. So yeah, basically it means that here it's not just an object, it's a mesh, and there is plenty, you can have plenty of them. So when, for example, if you take an object and you use 60 pixels, it looks like this on the screen of the user. If you zoom in on it, you know. And so the software here, as you can see, it turn around the object and try to take a screenshot of it like this, you see. And at the end, it gives you this effect of when it, you can see that here, for example, when it's far, the difference between the both of them, except the lighting, are really merging. I mean, which is this one or is it this one that is 3D? When you look from a far distance, it's really hard to guess. But when you look at close distance, you can really see the difference. For example, here it's 34 of diameter in pixel. And you can say it's the texture one because the 3D has the lighting on it. So you can always guess it's the texture, but not when it's a far distance. Here is an example of what it looked like when you have a town full of 2D objects. And here is the last version I did for the quest. So here you can see that this is the object 3D. And this is the asteroid moving around and turning around, and all that are just square with a texture where the UV is switching to make you guess, to make you believe it's a 3D object. It's really, really cool. So if you want a bit of number, I did another script that allow you to give a radius of the object you want. You put the Unity camera resolution to the one of the target you want. For example, for Quest 2, it's this resolution. And when you press play and wait a bit, he will produce you this table that say, okay, if the object is 1 of radius here, it means that you need a texture of those pixels to this distance. So it means that when you reach 25 of unity distance for an object of 1 unity distance, then you can use my tool, because technically you will never need more than those number of pixels to display the object. So for example, if your object is 60 and something of pixel, then it means that as soon as you are more than 50 distance, unity distance of the camera, then it's useless to use 3D, just use this 2D effect if you don't need the lighting. And so that's how the tool is used. But as you can see, if your object is more large, then the distance are more far. But once again, it's kind of good enough. I mean, if your object is at 200 of distance, you can use my technique for an object that is 5 of distance, 5 of height, of radius. So yeah, that's the idea of the tool. So let's try an example. So here is the tool. We will try to do a version here of the moon. So I did take my perfect sphere. I put a texture that is not quite perfect. So the 3D is perfect, but the texture is not perfect. But yeah, I just took from the web quickly. So you put your sphere in the center like this. You put this little point that will say this is the max radius I want to use. And so now, as you can see, I have this script that allow me to guess how many pixels it is far from the camera. So as you can see, I give the object and I give the radius of the object here to be able to make the camera look at this object. And then I have this script that allow me to record all the details. So what you do is you choose a color. So for example, if you want the background to be gray, you use that. If you want the background to be close of the object, you try to find a color that you like this one. Up. And it means that when it will take the screenshot, it will take the screenshot with this background. But you will see. Camera speed, it's how many the camera is moving far away from the object to guess the pixel. Here I'm saying that I want a texture of those number. The name is Venus. So here it will replace the name with Venus, the dimension texture with this. And you say how many the small square you want. So here it's 34. And when you are done, you say, come on guy, compute me that. So you press play. And yep. Where are you? Here. So here it's moving away from the planet until he understands that the planet is doing 64 pixels. So we can wait. As you can see, yeah, here. So here it's 64 pixels on the Quest resolution, as you can see here. And so he started to take screenshots, and as you can see, he took the point on the top of the object to be able to truncate. And as you can see here, he's producing two textures. One with a green screen that helped to have, sorry for stroboscopic aspect, one with a green screen that helped to have the alpha, so the black and white texture version. And here with the background that you asked to have for the border of the object to have the same color as, for example, here Unity will have some alpha, some junction between the background and your texture. So it's why you choose the color of the background to fit your object, because you will have this ugly background on the side of the texture. And now you just wait. I mean, as you can see, it's producing the stuff. And so yeah, that's the cool part of the tool. I mean, you will see what it gives a bit just after that. But basically, I can maybe already show you what it looked like. asset, no. So it creates in the folder that's called create texture here. It creates those texture, for example. And if you want to watch one, for example, this one was one of the first one. So I took the starship of Battlestar Galactica, I put it on the center, I put the anchor point, and I say, oh, can you produce me those number of dimension? And it produces that. And on the side, it produces this, if you want to use it. That example for this one, home. Home is a version, so you have to choose between the resolution of your object, but what I did a version with 2000 resolution. That is this one. As you can see, we have the home, but the problem is that you can see that the tweaking between the both of them is a bit. I want to have it in detail and to. So I did a version with the 4000 that look like this, and then you have largely enough rotation to have this feeling of, okay, it's the object, we can see that it's actually moving, but almost not. But the problem with this version is that it's a lot of resolution, so it will not be good for the performance of your quest if it is for one or two objects in the scene. But if you have thousands of objects like this, you have to guess, does it worth it or not? So it's a tweaking stuff that you need to do with your project. But basically, here is what it looked like if you want to have a big detail with a big resolution. But at the end, it could be useful. I know it's not the perfect stuff. I mean, if you are someone that is really skilled or mathematically or someone who already did an Impostor version, you are looking at me like, nope, because you don't need so many rotation. You could just make a script that is doing interpolation between this one and this one to be able to have less texture. And you could also remove this empty space by doing a version that compresses those textures. So there is plenty of stuff you can do to make it less heavy in the memory. But as I'm a noob, I was like, no, I will keep it simple because I just want to check if it's working. So there is improvement to do, but I won't do it because I don't have the time to do it for the moment. As you can see, it takes its time when you do a very big texture of it. But it was it, because at the end you have your what you want, a 2D texture that is moving really kind of a 3D, but not 3D when it's far. So yeah. On that, we will wait. So if you look at the video, feel free to skip a bit far because I don't know what I can show you without losing the subject. What can I show you? Or that there is nothing really interesting. Unity, it's here. So while it's doing its stuff, yeah, so it looks like this. As you can see, the idea is kind of simple. You have the planet here, you have the camera that is here, rotating around and taking the screenshots. And as you can see, I'm using the GPS location of a planet to be able to move my object around. So it means that you have 180 degree on the left, on the less on the right. You have 90 degree on the top and less 90 degree on the bottom. Is it the best solution? I'm not sure. Because there is a lot of texture repetition. And also you have to compute all those data to be able to put the good texture, to put the camera correctly. So in terms of computing, I think I lose a lot by using a GPS location. But at least it's helped me in the conception, and it helped me also because it's just trigonometry. So I just need to use MatScene, and MatScene is usable in a computer or in a job system. And it's why I use this methodology to produce my texture. What the code look like? For example, I can maybe look at that. Oof. I think I should have not done that because it's paused by opening Visual Studio, it paused Unity. I hope it's continuing. Okay, it's continuing. Yep. So the code, as you can see, Space Builder here. What is this one? What is the Space Impostor Builder? Camera color. Yeah, so that's the script of the recorder. As you can see, he is using another script here. I will go in the definition like this, because like this you have the both of the code. So this one, so it's ugly, dirty code. I mean, it's an experiment, so the code is hell, but it works. But it's an experiment here for the moment. So the idea here, how it's working, is just that you ask the camera, could you give me the pixel resolution of you? So it will give you what you set in Unity. And when you have that, you can say, could you give me the radius of the two transfer points the user gave me? Like this, as you have the radius, you can say, here is the center of the point, here is the up part and the right part of the point. So that's for debugging. And when you have those 2 or 3 numbers, what you do is that you use the camera wall to screen point to ask, okay, if I have those 2 points in the screen, what are the pixel position of them? And when you have the pixel position of them, you can do just the center less the right part. And like this, you have the number of pixel. If you do the absolute version, so remove the negative one, you have the pixel count for the radius of your object. As it's a radius, you multiply by 2 to have the dimension of the object. And like this, you just computed the dimension of the horizontal pixel of your object. And if you want to have an estimation of how many images you can fit in a texture of those numbers, then you divide by the number of pixels, and ta-da! For example, you can have 11 or 12 or something like that. It depends on what you choose. So this tool is just that. Okay, and so I did a more proper version of it, where what you do is you give the camera, you give the distance of the object, the radius of the object, and he computes you what resolution has been used and the horizontal pixel value. I'm not sure the vertical one is useful because basically it's the same as the horizontal one because it's a radius, so I will probably remove it. But here is a more cleaner version of it if you want to use it. I do exactly the same. Huh? So based on that here, I will do the moving camera part and taking the image. So as you can see here, I say, okay, when I start, I take the background of what the user wants. I start a coroutine because I want to be able to debug it, so I prefer to see it happen. And in any case, to take the screenshot, you need the rendering to has occurred. So every time you take a screenshot, you need to wait the next frame. It's why it takes a lot of time on the side here. It's because there is some I should use texture compute shader to copy paste the texture to go faster. But there is also the fact that I need to wait the rendering. So here we start. And say, okay, I have a camera with a speed and a distance. Until we find those pixels that the user is asking. Here, I want you to go far in the distance, so distance plus speed, until you reach those pixel dimension the user is asking. When you have those pixel dimension the user is asking, then we can start to prepare to be able to screenshot all that. So what you want is a dimension. It's 32, but it's because I use 32 at the start, but it's not 32. It's NN. So you use the dimension. You use a dimension texture and a dimension map texture. So two texture of the dimension the user wants. So you prepare all those data. And what you want to have is some degree horizontal. So how many degree the camera need to move on the horizontal axis and on the vertical axis. As I'm using the GPS coordinate, I don't need to do all the way because as I'm doing this, when I'm here, I just need to go up, but not too far. Because if I go too far, the camera will be on the other side, and I don't need it because I already have it, but in the other, you just need to rotate the Z and you have it. So that the computation I do on the other side is to guess with the texture you give me how the Z is disposed to be able to make the fake to the square on the goods. Yeah, it's complicated. But basically, yeah, we don't need to go all the way. So here you can see that I'm preparing all those data. And here it is the code of me turning around. So I say, okay, how many parts do we have? So I go from horizontal to vertical. So I'm doing that, but for the moment, I'm not sure I should, but you need to skip the zero index because basically you have a texture that is split by 2. So you skip the 0. And with those degree, you just move the camera a bit, like this. You do the quaternion and there's plenty of calculation, but basically you move the camera at the position you want and the rotation you want. You draw a line just to be able to debug. And then what you do is the camera, you put the background the user asked. You wait the end of the frame to be able to, because anyway Unity will say no, if you try to have the texture of the camera when it's not finished. So you wait the end of the frame, and then you cut a part of the camera to your small texture. And the same after that with color green behind. So when you have those cutting part of the screen, then what you do is you just, if the user give you some debug canvas, can debug it. Then you wait the next frame and you start back and you start back and you start back. And when you have finished, what you do is that you convert all those green pixel by transparency for the main texture and the alpha texture. So for example here I'm converting the texture where it's green to a black color and a white color. Yeah, that's for the part where I try to do the black and white texture. So I say if it's green, it's black. If it's not green, it's also other things, so it's white. So it's 1 and 0. And here I'm just saving the file. For the cutting part, if you are interested, there is 2 versions of it. There is the accessing the texture, because what happened is that you are using the rendering texture of the camera, so you just take a big texture and you put your rendering texture in the render texture of Unity to say it is the active one I want to copy from this one, and then you just say could you copy in my texture the one of the rendering texture, and like this you have the camera texture. When you have this camera texture, what you do is you ask to cut it So what happened in the cutting version, you just take the texture of the guy, and you copy all the pixel, and after that you go fetch from where you want to print the 2D texture to all the pixel that you want to write over, and you just write over it and then apply. So that here, I mean, you take the texture of your texture, you take the texture of the camera, and you just copy those pixels to your own texture. Yeah. The code is there. Try to understand it and try to use it. But that's the idea. It's finished on the other side. So we go back here. As you can see, he finished. So when you come back to Unity, he imported the texture. Yep. So hop. So now if we go to create texture, we should have Venus here. And ta-da! Plenty of 2D parts of Venus on all the angle. So what is cool now is that you can use my code of Impostor. So I will close the recording part like this. I will go to the play part like this. Up here. So what happened is that I have a script that generates plenty of Impostor. Yeah, shit. 2 seconds. So now we don't want to record, we want to play. So the idea is that here, as you can see, I just have something that generates me plenty of Impostor randomly. And what is an impostor is just a point in space that has where it is and what is the radius with based on a transfer point. You can use, in the future version, you can use whatever you want, transform, vector tree, whatever you want. The idea is just you give me where you want it and the radius of the object you want to fake. And you give it to step by step. You give it to this. So this is the code that will try to guess the rotation and generate a mesh and make the simulation. So here you say I want those maximum squad because as you are using the job system of you have a rigid version, so you cannot have a list. So as you cannot have a list, you need to say I want those maximum. Basically, I will show you directly an example. So here in my current version, I have those number of imposter. So I just need to switch the material texture. So here I go here, imposter tests. We don't want the one of the asteroid. We want the one of Venus. Like this. So I just switched the texture here, and if I press play, as you can see here, I have a list of 700 imposter. So when I will play, it will compute all those square and move them in a mesh. And so now, as you cannot see, because the camera is deactivated, I think. Yeah, ta-da! So why it's rotating is because it's some asteroid, so I put some script to rotate randomly. But here is what it looked like. Ta-da! And that's stupid, but it's work. So all the point over there are just some square with texture rotating to give you the feeling of having a 3D object. Ta-da! So if I move here, you can see that I need to have a shader to work a bit on the edge, because as you can see, the edge is really cut here. And more you are close of the object, more you see that it's just a texture, a 3D texture moving. But the idea is that here, when you're a bit far, not easy to say, huh? And so yeah, that's the idea of the tool. I mean, if you want something like this, you can use something like this. But if you switch the material, you can have those asteroids I told you earlier. So if I do house, asteroid, this, ta-da! And as you can see in the asteroid, we really see the border I told you that is a bit boring here, the white border. So I need to work a bit on that. But the idea is over there. So we'll go far closer because, yeah, as you can see, it's just a big mesh. And as you can see, when it's really close, you need to switch with the 3D model. But the stuff I was thinking about is that if you are doing a 2D game and you need to manufacture those 2D stuff, but you have plenty of 3D objects on your favorite website, or if you have an object that is in 3D in your game and you want to make it a 2D game with it, it's also really perfect because here you just put the object in the software and it take all the picture, and then you can move your object in your 2D world and it will try to guess what it should look like. So yeah, that's the idea. I mean, it's a long video explaining all that, but I was so happy to succeed to produce this tool that I wanted to at least have an archive of it. So here is the video. Hope you enjoyed. If you want to know more, feel free to contact me on Discord. If it's useful, feel free to send me a beer or a coffee on the link of the Coffee Illustré. And see you next time in the next video. Bye. May the code be with you.